Welcome to the video on vectors, products, angles, parallel, and perpendicular. First, we have the scalar or dot product. For this, you multiply each component of the vectors by each other and then add the results. So you'd multiply the x values by each other, the y values, and the z values, and you would add each of those results to get your final constant. That would be an answer. With your dot product, it doesn't matter which order you multiply it in, it'll be the same. When you have a dot product and a sum, you could do the sum first and then the dot product, or you could do the dot product of each one and then add them together. If you have a constant times a vector and then the dot product, you could do the dot product first and then multiply it by the constant. And then if you have a vector where you're doing the dot product to that same vector, the result should be the magnitude of the vector squared. So if you had two vectors, for example, that were 2, 3, 1, dot, -1, 6, 2, all you would have to do is multiply each one. So 2 times -1 is -2, plus 3 times 6 is 18, plus 1 times 2 is 2. So this would equal 18. So that's how you do a scalar or dot product. Next, we want to find the angle between vectors. So if you have two vectors, there's an angle in between them, and to find that, you'll use this equation here. So the scalar product of v and w equals the magnitude of v times the magnitude of w times the cosine of theta. So if w was equal to 8, 2, and v was equal to 1, 5, then we could figure out the angle in between by doing the dot product, 1, 5, dot 8, 2, equals the magnitude of v, so the square root of 1 squared plus 5 squared, times the magnitude of w, so the square root of 8 squared plus 2 squared, times your cosine of that angle. So our dot product would be 8 plus 10 equals the square root of 1 squared plus 5 squared, so 1 plus 25, so the square root of 26, times the square root of 8 squared plus 2 squared, so 64 plus 4, so the square root of 68, times your cosine of theta. So you have 18, and then we'll divide both sides by the square root of 26 times the square root of 68, and that will equal your cosine of theta. We could do more simplifying, or we can just take the inverse cosine of 18 over the square root of 26 times the square root of 68, and that would equal theta. So our angle here would be approximately 64.7 degrees. So that's how you would find your angle. Finally, we have parallel and perpendicular vectors. Parallel vectors are if the magnitude of v dot w equals the magnitude of v times the magnitude of w. So if that's true, then the vectors are parallel. So if we're given two parallel vectors, for example, so we'll have v and w, and we'll say v is 1, 2, 3, and w is twice that, so 2, 4, 6. We could find the magnitude of v dot w and see if that's equal to the magnitude of v times the magnitude of w. So our v dot w is 1 times 2, which is 2, plus 2 times 4, which is 8, plus 3 times 6, which is 18. So we'll do the magnitude of that equals our magnitude of 1, 2, 3, which is the square root of 1 squared plus 2 squared plus 3 squared, times our magnitude of 2, 4, 6, which is the square root of 2 squared plus 4 squared plus 6 squared. So 2 plus 8 plus 18 will give us 28. So the magnitude of that is just 28. equals the square root. 1 squared is 1, 2 squared is 4, 3 squared is 9, and then the square root of 2 squared, which is 4, 4 squared is 16, 6 squared is 36. So 28 equals the square root of 14 times the square root of 56. So 28 is the square root of 14 times 56. 56 is the same as 14 times 4, and 4 is 2 times 2. So we have a group of 14s and a group of 2, so we could pull out 14 times 2, which is 28. So we get that 28 equals 28. So we know that these vectors are parallel. For perpendicular vectors, if v dot w equals 0, and neither of the vectors is a 0 vector, then the vectors are perpendicular. So if we had v and w, where v is 0, 1, 3, and w is 1, 5, negative 5/3, we can see if these are perpendicular by taking v, 0, 1, 3, dot w, 1, 5, negative 5/3. So we'd have 0 times 1 is 0, plus 1 times 5 is 5, plus 3 times negative 5/3 is negative 5. So we have 0 plus 5 minus 5, and that equals 0. So since that equals 0, that means that these two vectors are perpendicular. So here we have our first IB practice question. The calculator is allowed for this. It says, given A equals 2, 3, negative 1, B equals 0, 4, 12, C equals 5, 7.5, negative 2.5, and D equals 1, 5, 2, are the following parallel, perpendicular, or neither? So first we have vectors A and B. So we can start by testing if they're parallel. So if they're parallel, A dot B should equal A, B. So A dot B would be 2, 3, negative 1, dot 0, 4, 12. And we want to see if that equals the magnitude of 2, 3, negative 1 times 0, 4, 12. So 2 times 3 is 0, plus 3 times 4 is 12, and then negative 1 times 12 is negative 12. So we can already see here that the dot product is 0, so we can immediately go to the fact that they're going to be perpendicular. So we'll write that here, perpendicular. Then we have vectors B and C. So we'll have 0, 4, 12, dot 5, 7.5, negative 2.5 equals the magnitude of 0, 4, 12 times the magnitude of 5, 7.5, negative 2.5. So our dot product will be 0. 4 times 7.5 is 30, so plus 30. And then 12 times negative 2.5 is negative 30. And once again, we can see that this is 0, so we can automatically jump to the conclusion that they're going to be perpendicular. Finally, we have vectors A and D. So we'll have the magnitude of 2, 3, negative 1, dot 1, 5, 2 equals the magnitude of 2, 3, negative 1 times the magnitude of 1, 5, 2. So this will equal 2 plus 15 minus 2 equals the square root of 2 squared plus 3 squared plus negative 1 squared times the square root of 1 squared plus 5 squared plus 2 squared. So our magnitude over here is going to be 15. Since this dot product wasn't 0, we know they're not perpendicular. And this has to equal the square root of 2 squared, which is 4, plus 3 squared, which is 9, plus negative 1 squared, which is 1, times the square root of 1 squared, which is 1, plus 5 squared, which is 25, plus 2 squared, which is 4. So 15 equals the square root of 14 times the square root of 30. So that means 15 equals the square root of 14 times 30, which is the square root of 420. And that's not equal to 15, so they're not parallel either. So they're neither. But if we look back at A and B, we can see that A and B are perpendicular and B and C are perpendicular. So we could do the math and find out that A and C are parallel. So those are the solutions to this question. So here we have our second IB practice question. It says given V equals 1, 4, negative 1 and W equals 2, 3, 1, find the scalar product of the vectors and the angle between them. So our scalar product is V dot W. So that equals 1, 4, negative 1 dot 2, 3, 1. So we have 1 times 2, which is 2, plus 4 times 3, which is 12, plus negative 1 times 1, which is negative 1. So that will equal 13. So the scalar product is 13, and the angle between them we can find using the formula V dot W equals the magnitude of V times the magnitude of W times the cosine of theta. So we did V dot W, so we know 13 equals the magnitude of V times the magnitude of W times our cosine of theta. So 13 equals the square root of 1 squared plus 4 squared plus negative 1 squared times the square root of 2 squared plus 3 squared plus 1 squared times our cosine of theta. So 13 equals the square root of 1 squared, which is 1, plus 4 squared, which is 16, plus negative 1 squared, which is 1, times the square root of 2 squared, which is 4, plus 3 squared, which is 9, plus 1 squared, which is 1, times the cosine of theta. So 13 equals the square root of 18 times the square root of 14 times the cosine of theta. 18 times 14 is 252, so we have 13 equals the square root of 252 times the cosine of theta. We'll divide by the square root of 252, and then we'll take the inverse cosine of both sides. So we'll get cosine inverse of 13 over square root of 252 equals theta. So theta is approximately 35 degrees. So we have our scalar product and our angle between the vectors. So in summary, our scalar product is found when you multiply each component of the vectors by each other and then add the results. We have our equation here and different rules to go with it here. The angle between the vectors can be found using the equation V dot W equals the magnitude of V times the magnitude of W times the cosine of theta, where theta is the angle between V and W. You can find parallel vectors because if the magnitude of V dot W is equal to the magnitude of V times the magnitude of W, then the vectors are parallel. And you can find perpendicular vectors by finding if V dot W equals 0 and neither of the vectors is the 0 vector. That's all for this video. Thank you for watching.